Perfect concrete still fails container homes. You can pour the strongest slab or the deepest piers, follow every rule, and your foundation can still be the single point of failure for your entire project. The debate between piers and slabs that you see online is a distraction from the real problem. The real problem is happening in the soil, and it starts with a fundamental misunderstanding of the structure you are trying to support. The most common question builders ask is, should I use a concrete slab or concrete piers? This is the wrong question. It focuses on the material, the concrete, and not on the engineering force that actually causes the failure. Both a slab and a pier foundation can be incredibly strong, and both can fail catastrophically. The failure doesn't come from the concrete cracking, it comes from the ground moving underneath it. Placing your trust in the strength of the concrete without first mastering the behavior of the soil is the single most common assumption that leads to disaster. The true enemy of a container home foundation is a concept engineers call differential settlement. This simply means that the ground under your foundation settles or sinks unevenly. One corner might sink half an inch, while the others remain stable. For a flexible wood frame house, this is a problem. For a rigid steel container, it is a catastrophe. The reason this is so critical is load concentration. The entire 8,000-pound weight of a standard container, plus the weight of its interior, is channeled down to just 4 incredibly small points, the corner castings. The pressure at these points is immense. If the soil under one of these points is weaker or wetter than the others, that corner will sink. This uneven support puts the entire rigid steel frame of the container under a constant torsional load, a twisting force it was never designed to handle. This is where most online advice fails. It applies the logic of a conventional house to a container, and this is a critical error. A traditional house foundation supports a distributed load along a continuous sill plate. The weight is spread out. A container is point-loaded. It is an entirely different engineering problem. This is why even a massive, thick concrete slab can fail. If the subgrade, the prepared soil beneath the slab, is not perfectly uniform in its compaction and drainage, one area may settle more than another over time. That slight dip in the slab will create the exact same twisting force on the container as a sinking pier. The problem was never the concrete, it was the assumption that the ground beneath it was a perfectly stable, uniform platform. It rarely is. The professional solution is to stop thinking about the foundation as a separate entity. You must think of it as one part of an integrated soil and structure system. The first step is always to understand the soil. A simple soil test or a geotechnical report tells you its load-bearing capacity. This is a non-negotiable prerequisite. The second step is to design a foundation where the supports align perfectly with the container's natural load paths, primarily the 4 corner posts. The final and critical step is to ensure that each of those support points has a footing that is engineered to spread the immense concentrated load safely onto your specific type of soil. The weaker the soil, the wider the footing must be. This is what prevents differential settlement. You are not just building on the ground, you are building a stable interface with the ground. Concrete doesn't fail. Assumptions do.